All right, in this video we're going to look at a couple more examples of integration by parts. So if you have the integral of u dv, that is equal to uv minus the integral of v du. And so I think we're on our third example here. We're going to look at integrating 5x squared divided by e to the 2x dx. We'll go ahead and slide the 5 out and rewrite that as x squared e to the negative 2x dx. Okay, and then your book mentions the Lyot, okay, as a means of kind of helping you with what your u should be. So first it should be a logarithm if there is any, then inverse trig, then algebraic expressions, functions, trigonometric, and an exponential. So here we do have a algebraic. We have the x squared. So for our integration by parts, we're going to let u equal x squared. And our dv will be the rest of the integrand, which will be e to the negative 2x dx. Differential du is 2x dx. And then v will be negative 1/2 e to the negative 2x. Okay, so this is going to be 5 integral of u dv. So we have that correct, and so we can apply the integration by parts formula, which is going to be 5 times uv minus the integral of v du. So it's going to be 5. U is x squared. V is the negative 1/2 e to the negative 2x. So we'll go ahead and switch the order there and say negative 1/2 x squared e to the negative 2x minus the integral of 2x, which is part of the du, and then minus 1/2 e to the negative 2x, that's the v, and then the rest of the du is dx. We'll just go ahead and switch the order a little bit. Okay. All right, so this is going to be 5 times minus 1/2 x squared e to the minus 2x plus the integral of x e to the negative 2x dx. So the 2 and the 1/2 absorbed, and then the minus signs also absorbed. Okay. Now x e to the negative 2x, we can't quite do a u substitution on that one, so we're going to do a second integration by parts. So we're going to let u equal x. Differential dv will be the rest, which will be e to the negative 2x dx, the rest of the integrand. Differential du will be dx, and v will be minus 1/2 e to the negative 2x. Okay, so it's going to be 5 times negative 1/2 x squared e to the minus 2x plus the integral of u dv. So we have that, and we can go ahead and apply the integration by parts formula. It's going to be 5 times negative 1/2 x squared e to the negative 2x plus uv minus the integral of v du. So 5 times negative 1/2 x squared e to the negative 2x plus negative 1/2 x e to the negative 2x minus negative 1/2 e to the negative 2x dx. Okay. All right. So we're just about out of room here, but this last integral right here, that's just a regular integral there, so there's nothing special about that. So we're ready to integrate that. Let's go ahead and look on the next page here. So we're just going to go ahead and rewrite where we were at. Okay, so we got 5 times negative 1/2 x squared e to the minus 2x minus 1/2 x e to the negative 2x plus 1/2 times negative 1/2 e to the 2x plus c. We should probably put this here. It actually doesn't matter here, but we're going to put that there, that bracket there. All right, let's go ahead and distribute the 5 through. So we have negative 5/4. Is that what I did? No, that's not what I did. What I did here is, let's see, we got a denominator of 4 there, so we're going to factor out a 4. So when we factor out a 4, that means we're going to divide this, I factored out a 1/4, so it means I'm going to divide both of these by 1/4 there. So those are going to become 2. So I factored out a 1/4. I also factored out e to the minus 2x, and all the terms were negative, so that's what happened there. Okay, so what do we got left here? So we got 2x squared plus 2x and plus 1, and then plus your constant of integration. Now you can certainly check and distribute to make sure that is correct. We're also going to verify that we do have the correct antiderivative here. We're going to go ahead and differentiate this. So the derivative of negative 5/4 e to the negative 2x times 2x squared plus 2x plus 1 plus the constant of integration. So negative 5/4 times negative 2e to the negative 2x times 2x squared plus 2x plus 1. So derivative of the first function times the second function plus the first function, e to the negative 2x, times derivative of the second function, which is 2x squared plus 2x plus 1. Derivative of that would be 4x plus 2. And derivative of the constant of integration, that's gone. All right, so negative 5/4. Factor out e to the negative 2x. And distribute the negative 2, so we have negative 4x squared minus 4x minus 2 plus 4x plus 2. It's going to give us negative 5/4 e to the negative 2x times negative 4x squared. Okay, and that's going to be 5x squared over e to the 2x, and that was the original integrand, so that looks like that worked out correctly. Okay, I think we got one more example here. Let's check it out. Okay, so we got the integral of x cubed, natural log of 4x dx. Again, so for our liants here, we'll start out with our u probably being the logarithms. Okay, so that's what comes first. All right, so u is the natural log of 4x. Differential dv will be the rest of the integrand, x cubed dx. So differential du is 1 over 4x times 4 by the chain rule, dx. And v will be x to the 4th over 4. Okay, so this can be rewritten as the integral of u dv, which is equal to uv minus the integral of v du. uv is going to be natural log of 4x times 1/4 x to the 4th. So let's go ahead and put the v first. So 1/4 x to the 4th, natural log of 4x minus the integral of v 1/4 x to the 4th du 1 over x dx. That's going to be 1/4 x to the 4th natural log of 4x minus 1/4 integral of x cubed dx. So 1/4 x to the 4th natural log of 4x minus 1/4 times x to the 4th over 4 plus c. So 1/4 x to the 4th natural log of 4x minus x to the 4th over 16 plus constant integration. Factor out the 1/16 x to the 4th, and we have 4 natural log of 4x minus 1 plus constant integration. Okay, if you want to check it, you take the derivative of that. So that's going to be 1 over 16 times 4x cubed times the second function of 4 natural log of 4x minus 1 plus the first function of x to the 4th times the derivative of natural log of 4x, which is 4. Yeah, so times the derivative 4 natural log of 4x minus 1. So you got the 4. Derivative of natural log of 4x would be 1 over 4x times 4 by the chain rule. Derivative of the 1 would be 0. So 1 over 16, 16x cubed natural log of 4x minus 4x cubed plus 4x cubed. Okay. And so that simplifies down to x cubed natural log of 4x. Which was the original integrand. Okay. All right, stay tuned for the next video for a couple more examples.